Hi everyone, let's take a look at this technique known as substitution. So here's example 1, and it says to solve. Solve means find the value of x and the value of y. Okay, so let's look at the example. First off, you notice you're given y equals minus 2. And that's actually like a first equation. So we're going to write a 1 here and we're going to circle it. This is the first equation. Then we're given y equals 3x plus 1. That's a second equation. Okay, so you're always going to have two equations when you do substitution. If you want to take a look at those equations graphically, here's what you get. So here we see the x-axis, okay, and then up to the sky, y to the sky is the y-axis. And I've graphed both of those lines. So the first line was y equals minus 2, so it's at y equals minus 2 everywhere. And the second line's at y equals 3x plus 1, okay? And again, I started at 1, and I went up 1, 2, 3, and over 1. That's because this slope is 3 over 1. Rise over run. Then when you consider where these two lines meet, which is right here, we called that a point of intersection, a POI. And it turns out that it's at minus 1, minus 2. So if you take a look back at what we did here, we graphed the two lines, and now we can visually see where they intersect. They intersect at minus 1, minus 2, where they meet. And this would be the graphical way of doing it. Going back to substitution, we can do this without graphing it. So that's what we're going to learn. We're going to learn where these two lines would meet, but we're not going to graph it. We're going to use the technique substitution. So to do substitution, there's some steps, and only through seeing examples will you see the steps more and more and become comfortable. So let's try this one. Here's the usual first step. You've got two equations, and you look at them, and you're hoping that one of the variables is by itself. So look at y. He's by itself, and it equals minus 2, so we're already set up for that. The second equation has that as well. Y is by itself. So this is a good, easy to start with substitution example. We want a variable by itself. Now that we see that, here's this first key step. You write out the following. You have to write this out. You have to show your work. You write sub, which means to substitute. It's substitution. Okay? You're going to sub equation 1 into equation 2. And here's what goes on. See how y is equal to minus 2? What you're going to do from equation 1, anywhere you see a y in equation 2, you'll substitute the y out and write minus 2 instead. So watch this. I'm going to write equation 2 down, but instead of writing the y, I'm going to use insertion brackets. Okay, so I'm writing this equation down, but instead of writing y, I'm using brackets to show that I'm substituting a minus 2 in instead. Because we learned from equation 1, y equals minus 2. We're going to take this minus 2 and substitute it in, like, right here. Okay? So if I keep going, the second equation says y equals 3x plus 1. I've substituted minus 2. Now I write the rest out. 3x plus 1. What's left to do now is what's called solving. Okay? So let's clean this up. This is really just minus 2 equals 3x plus 1. Now we need to work on solving this. In the last few weeks, we've done a lot of solving, so just remind you what that means. When we see that minus 2 equals 3x plus 1, what we want to uncover is just what x is. We want to solve for x. And there's lots of stuff happening to x here. It's being multiplied by 3, and there's 1 added to it. So we have to undo everything that's happening to it. Okay? And we go backwards. We deal first with getting rid of the additions, subtractions. So it says 3x plus 1. We're going to need to do the following. So we're going to subtract 1. And if we subtract 1, we have to do it on this side as well. You got to be fair to both sides. And now you update. Negative 2 subtract negative 1 is negative 3. Carry the equal sign down. Can't do anything with 3 times x yet. Plus 1 minus 1 is 0, so you're just left with 3x. Okay? Now you need to undo 3 times x, and to undo 3 times x, you have to divide the 3 out, and you have to do it on both sides. Okay? That causes this to cancel. There's no more 3's in front of our x, and you're left with x, and minus 3 divided by 3 is minus 1, and you've solved for x. In fact, you know that the point of intersection for these two lines, you know you need to write it out now because you have everything that's available. A point of intersection, like it happens at an x value and a y value, and we just learned that, well, this thing meets at x equals minus 1, which we found, and we know they have to meet at y equals minus 2 earlier, because that other equation only exists at y equals minus 2. So the y value would be minus 2. And this has to check out, okay, minus 1, minus 2, with that graph we saw earlier. As you can see here, it does. Minus 1, minus 2 was where our two lines, when graphed, meet up at a point of intersection. Let's try a second example, and this is going to become a medium difficulty. The other one was more of an easier difficulty. So this would be considered moving into like a medium difficulty substitution. All right, and this comes from the worksheet I'm going to give you, worksheet number 3. Here we see we've got an equation, y equals 4x minus 6. That's the equation of line number 1. Then you have the other equation, 3x plus y equals 8. That's an equation for a second line. And we always label this. You have to write that down, 1 and 2. All right? So then you ask yourself, is one of these equations set up so the variable is by itself? Okay, so you think to yourself, who is by itself? And that's number 1. Okay, number 1 has y equals by itself. Once you've determined that, the next step you want to take is that key step, and you have to write it out. You do this. You write sub what's part of equation 1 into equation 2. And here's what that means. From equation 1, we learned that y is the same thing as 4 times x take away 6. So y is equal to 4 times x take away 6. We're going to sub what that stuff that belongs in 1 that I just discussed into 2. So anywhere we see a y in equation 2, right here, instead of writing y, we're going to write all of this because it's equivalent. And here's how that looks. So I'm going to write equation 2 out, 3x, I'm going to write it all out this time, plus y equals 8. But anywhere I see a y, as this is equation 2, I see a y, it's equivalent to, from equation 1, 4x minus 6. So now what happens? 3x plus, now use the brackets for substitution. I'm not writing y, I'm substituting 4x minus 6. Okay, now I update. Think about this. There's 3x, and you can add that 4x with it. Okay, 3x plus 4x, we would have 7 x's. So there's 7 x's, and then the minus 6 equals 8. Okay, now we have to continue using our equation solving skills we've discussed in the last number of weeks. We want to find out what x's we want to solve. And to solve, we have to undo the addition subtractions and then undo the multiplication divisions. And let's see what we have here. Here we see 7x is having 6 subtracted from it. We can use the trick where if you send this minus 6 over to the other side, that minus 6 comes over to this side, and it's no longer subtract 6, okay? It becomes plus 6. So you'd have 8 plus 6. It's just it changes sides, and you have to flip the sign from negative to positive. Okay, that's a trick you're able to do. What's left then, if this minus 6 came over to the other side, you still have the 7x remaining there. Okay? Then you have to use your equation solving skills, and you can kind of update this. Well, 7x is still 7x. 8 plus 6 is 14. Okay? And this is a lot cleaner. You got rid of the addition subtractions. And now the only thing left to get rid of is the multiplication divisions. So let's see what we have here. We have 7 times x equals 14. Just by inspection, we know that that should be 2. But let's do it with the right step method here. So we're going to divide the 7 out on both sides. And we realize x would equal 2. Okay, so that's one answer. A POI, a point of intersection, is going to need 2. You need to find the x value, and you need to find the y value. In example 1 earlier, the y value was already known. We were told it was already y equals minus 2 in example 1. Here in example 2, you need to go find y. So there's one more step. You actually have to do another substitution. So you see how you figured out x equals 2? Watch what you do with that now. This last step, we sub our answer of x equal 2 into that first equation we used. Remember the first equation was y equals 4x minus 6? Okay, it's at the beginning of the question. It's time to change gears, and this time we're going to substitute x in to go figure out the missing y value. So anywhere I see x, I put brackets, and I substitute the 2 in. So it's not 4 times x, it's 4 times 2, because we've learned x is 2. And then you just have to work out what the equation says. Here it says y equals, well, 4 times 2 is 8. Take away 6. Okay, so I guess this is neat. This one works out where y also equals 2. So now that you have the x value and the y value, you now have the point of intersection. So we use these concluding dots. I conclude that the point of intersection, okay, you just write it in order. You put the x value first, so 2, and then you put the y value, which also happens to be 2. So these two lines, if we were to graph them, they would meet at the point 2, 2 on the xy grid.